Okay, welcome to AP Stats Quideo number 4. So the basic question says that the Census Bureau reports that households spend an average of 31% of their total spending on housing. And then there's a home builders association in Cleveland that believes that their average is lower in their area. So they interview a sample of 40 households in Cleveland to learn what percent of their spending goes toward housing. And then it says take the mu to be the mean percent of spending devoted to housing among all Cleveland households, and we want to test this hypothesis. So it's given us our ho and our ha, or our null hypothesis and our alternative hypothesis. And it says that this population standard deviation is 9.6. Okay, so question A asks us to sketch the sampling distribution curve and show where the mu is and the standard deviation is on the normal curve. So I have here my sketched distribution. I have noted the different key numbers here, my ho and my ha, my n, which equals 40 because they interviewed 40 households, the original standard deviation, and then this standard deviation of x bar, which is 1.518. So this is my normal curve. 31% is my mean, and then each of these little tick marks represents a standard deviation. So for B, it says, suppose the study finds that x bar equals 30.2 for the 40 households in the sample, and asks to mark this on the axis in our sketch. And then suppose that the study result is x bar equals 27.6%, and to also mark this point in our sketch. And then to explain in simple language why one result is good evidence that average Cleveland spending on housing is less than 31%, while the other is not. And I said, first I marked them here, and then I said 30.2% is fairly close to the middle, while 27.6% lies out toward the low tail. If you assume that the null hypothesis is true, or the ho, 30.2% would be surprising and 27.6% is unlikely, and that provides evidence against the ho. So basically 30.2 would be more believable because it's closer to the actual mean, but it's still lower, which provides evidence that the overall spending in Cleveland is lower. And then question C says to shade the area under the curve that gives the p-value for the result x equals 30.2. So basically you go where the point is 30.2 on your graph, and I have shaded everything below that. Alright, so for the advanced question, it says that Pew Research in November 2011 polled a random sample of 799 U.S. teens about their internet use. 49% of those teens reported that they had misrepresented their age to an online to gain access to websites and online services. So it asks us to find the margin of error if we want a 95% confidence in our estimate. So what you do is you first have to establish your variables. Our p hat is going to be the number of people who misrepresented their age, and our n is just the number of people surveyed. First you have to find the little q hat, which is 1 minus p hat, and that equals 0.51. And then to find the margin of error, z star is 1.96, which if you look on the z-score table, you can find that for the 95% confidence interval, it is a corresponding thing. And then you just plug in all of your numbers, because p hat, q hat, all over n, and then square rooted, and then 1.96 on the outside. And that gets you this number, which gets you down to 0.035, which is your margin of error. And then it asks to explain what margin of error means in context. So it means that we are 3.5% uncertain at estimating the total amount of teens who misrepresented their age. And then C is asking us if we only needed to be 90% confident, will the margin of error be larger or smaller? And the margin of error will be smaller because the critical value will be smaller, which means that this value right here is going to be smaller if we have a 90% confidence interval, which means that the overall number will be smaller. Okay, so for our AP question, it says that each person in a random sample of 1,026 adults in the United States was asked the following question, and then it states the question, and then it gives us the results of the different answers. So A asks us to find a 95% confidence interval for the proportion of all United States adults who would respond to make some major changes to the question, and then to give an interpretation of the confidence interval and give an interpretation of the confidence level. Okay, so I have plugged in all of our numbers to our test right here. So we are testing and giving a confidence interval right here. And so our confidence interval ends up being 0.3602 and then 0.4198. And interpreting that confidence interval, I can say that we are 95% confident that the number of United States adults who would respond make some changes is between 36 and 42%, which is what I was given right here. And then for my confidence level, I can say that 95% of the intervals generated with this method will contain the true demographics, which is the stuff up here between 36 and 42%, with that 5% error rate because it's only 95% and not 100. Of course, all of these numbers represent standard deviation, N, P hat, Q hat, all of that stuff. And then B asks us, an advocate for leaving the system as it is now commented, based on this poll, only 39% of adults in the sample responded with what they want, that they want some major changes made to the system, while 41% responded that they only want minor changes or no changes at all. Therefore, we should not change the system. And to explain why this statement, while technically correct, is actually misleading. And I said that it was misleading because it discounted the 19% of people who said that they wanted to completely overhaul the system. And that added with the people who wanted to make major changes is 58%, which ends up giving you over half of the total sample size.